Okay, the learning target, find the domain, range, and vertex of a quadratic function and its inverse. So quadratic functions. We should remember these from algebra. Quadratic function is a function f of the form f of x equals ax squared plus bx plus c, where a, b, and c are constants and a cannot equal to 0. A can't equal to 0 because if it does, then we just have a linear function. So if we're going to call it quadratic, a, the coefficient of x squared has to be non-zero. So a parabola is the graph of a quadratic function, and the vertex of a parabola is the point where the line of symmetry of the parabola intersects the parabola. So here's an example of two parabolas. Parabolas either open down as this one does, or open up as this one does. And so the line of symmetry is the line that splits these in half. And these points where the line of symmetry intersects the parabola, that is the vertex. I like to think of it as the vertex as the peak. It's the top of this one. It's the maximum output of this function. Then over here, the vertex on one that opens up, the vertex is the minimum. Again, on one that opens down, the vertex is the max up here. That point is the max. And when that opens up, the vertex is that min. So let's jump into an example. Let's suppose f is the function defined by f of x equals x squared plus 6x plus 11. We want to find the domain, range, and vertex of f. So everything's going to depend on the vertex. So that's going to be the first thing we find. So what we're going to need to do is put this in the specific form, and we're going to use the method completing the square. If you've had trouble completing the square, there is a podcast that goes deeply into the method of completing the square. I'm going to proceed here assuming that you have a working understanding of how to complete the square. So look at the term, this part of my function x squared plus 6x. I'm going to complete the square on it. So what I do is take half of my coefficient of x, square it, and add it. And since I added 9 to keep my equality sign, I have to subtract 9. Thus I did nothing. I added 9 and subtracted 9, so I did nothing. That's a plus 11. But what I did is wrote this in a way that I can rewrite it where I can easily see the vertex. So x squared plus 6x plus 3 squared, that is the perfect square, x plus 3 squared. And that minus 9 and that plus 11 gives me the plus 2. And from our work on transformation of functions, we should know here that we have the vertex is located at, we go over to the right, or no, plus 3, so we go to the left 3 and up 2. So our vertex is located at negative 3, 2. And we know that since the coefficient of x squared here is positive, that this thing is opening up. And we know that the domain of any quadratic is always all real numbers, but the range is determined by this vertex and whether it's opening up or down. So it's opening up, and the vertex is at negative 3, up 2, so that means 2 is the minimum. So the range of this function f is going to be 2 to infinity. Find the domain and range of the inverse of this function. Note that quadratics are not one-to-one functions, so we must restrict the domain to make it invertible. Customarily, we restrict the domain to the right half of the parabola. You could restrict the domain in several different ways, but this is the standard data. Is when we're talking about quadratic functions, we restrict it to the right half of the parabola. So we know from our previous work, this is the same function we were just working on, that we need to restrict the domain to negative 3 to infinity. And we know that the range of f on the restricted domain is going to be 2 to infinity. So remember that our vertex was located at negative 3, 2. So the right half of that gives me a domain of negative 3 to infinity, and the range is still going to be 2 to infinity. So the domain of f inverse is the range of f, which is 2 to infinity. And the range of f inverse is the domain of f, which is, again, this is our restricted domain, a -3 to infinity. Let's do another example. Let's have the function -3x squared plus 5x plus 1. We want to do the same thing. Again, the first thing we want to do is find the vertex, because that tells us everything. So we're going to do the same thing we did before, but it's a little tougher because before we didn't, our coefficient of x squared was 1. Now we have this coefficient of -3. And to use the method of completing the square, we have to have a coefficient of 1 on x squared. So we have to factor that -3 out. So -3 factored out, these -3x squared. And the next one can be tough. -3 factored out of 5 is a -5/3. What you have to do is make sure that it multiplies back. So -3 times x squared gives me my -3x squared. And -3 times a -5/3. Negatives cancel, 3's cancel, gives me my 5x back. So we're good. And there's the +1. So we've done legal moves, we've not changed anything. So we're going to complete the square inside the parentheses here. So we get -3 times x squared minus 5/3 x. Now to complete the square, I need to take half of -5/3, which is a -5/6, square it, and add it. So -5/6 squared. Remember, and note that that is 25/36. So we added 25/36. So we must subtract 25/36 and then add 1 onto the end to keep the 1 that we have going here. And make sure that this 25/36 is inside the parentheses, because it has to get hit by this 3 when it distributes. So now the x squared minus 5/3 x plus a -5/6 squared gives me the perfect square, x minus 5/6 squared. So that's where the -3 times that comes. And then -3 times a -25/36 is going to reduce to a positive 25/12 plus 1. And so here is what we've reduced f of x to. And we have the vertex is so it's going to be over 5/6 up 37/12. And now we can use that. We know the domain of any quadratic is always all real numbers. The range is going to depend on the vertex and if it opens up or down. So the vertex is here and it opens down, so we know 37/12 is the highest value that this function obtains. So it's a -infinity to 37/12. The domain of f inverse is the range of f, -8 to 37/12. And the range of f inverse is the restricted domain. We take the right half of this parabola, so from 5/6 and to the right, so 5/6 to infinity. That will conclude this video lesson. This is a tough learning target, and I really advise you to rewind it, to stop it, pause it in places that you don't understand, and this concept of completing the square will come up on a couple different tests. So you really want to get this down. Thank you.